Good evening, guys. So let's proceed. So yesterday we had done till two category classification. Means before two category classification. So I hope that you have gone through my video, and means if you had any problems, you can again I'm saying that you can write me in WhatsApp that whether voice clarity, seeing blackboard, or any other means way of means conversation. If there is any problem, you can freely approach me and tell me. Otherwise, actually I will not be able to know that whether you guys are following, and the entire purpose of my taking this putting up this trouble of doing all this setup will be just going waste. Okay, so it's my request again and again to my dear students that due to shortage of time I will not be able to take my regular classes as means I used to do, and for this reason means I am have devised this method. So let's now go back to our topic. So I hope that you have given a thorough reading of the previous topics which we had discussed about the loss function, then expected loss function. Then we had also done it means we had also talked about overall risk, then bias risk, conditional risk. We have all talked about all these things. So I hope that you had gone through them. If you have not gone through them, then you should go through them before attending this particular video. Otherwise, you will not be able to understand a single thing. Okay. Now, let's go back to our topic. Now we go to two category classification. What is two category classification? See, guys, yesterday in the last video, we were actually saying means we were setting up indexes like I, J, like this, isn't it? So I, what means told you that alpha I means the decision which is to be taken. Okay, the decision which I have to take, and for categorizing means feature x I into class omega j. Okay, and I also told you that the distance between I and j must be as much as small as possible, because so that this particular function lambda alpha slash omega j is as much as small as possible, because if this function is small, okay, then what will happen is the overall risk or the conditional risk that will also become small, because that is a product of this particular term and my posterior probability. Posterior probability I discussed in last video cannot change, so this particular function I have to minimize as much as possible. Now, see over here, we have I and J. Now, how many classes we were talking about yesterday? I said that we had actually C number of classes. So they were we were renaming them as say omega 1, omega 2, omega 1, omega 2, omega 3, dot 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 omega C. Okay, and how many actions we were taking? Alpha 1, alpha 2, dot 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 alpha A. Now, in this two class problem, only there will be actually two uh, there will be actually two classes, omega 1 and omega 2. Okay, and the name, and that is why the name of this problem is two class problem. So there are two classes, again I repeat, omega 1 and omega 2. Now let's go back, all of you just have a look in your PDFs. Okay, two category classification. Please just go to your PDF from where you left yesterday. So I start reading. Now let us consider these results when applied to a special case of two category classification problem. Two category classification means the value of omega will be omega 1 and omega 2. Here action alpha 1. So we will have here over here two actions, alpha 1 and alpha 2, because there are two classes, omega 1, omega 2. So our categorization will be only in omega 1 or either in omega 2. So how many decisions we can make at most? Either alpha 1 or alpha 2. If this is clear, then I start reading. Here, action alpha 1 corresponds to deciding that the true state of nature, already explained true state of nature means the class itself, okay, is omega 1, and action alpha 2 corresponds to deciding that it is omega 2. For notational simplicity, let alpha ij is equal to lambda ij is equal to lambda alpha I omega j. So, what we are saying, say omega 1 and omega 2, say so alpha 1 will talk about categorizing that particular feature, say x, okay, inside this omega 1 class, and alpha 2 means categorizing this particular feature x bar, sorry, over here x bar means feature vector inside the class omega 2. Okay, so what we will have over here, we will have lambda alpha 1, slash omega j, that will be my, sorry, omega 1, that either that will be my loss function alpha 1 slash omega 2, that will be my loss function, or we can have lambda alpha 2 slash omega 1, or that may be the loss function. Okay, so this is I and this is j, or this is I and this is j. Lambda, when I'm taking decision alpha 1, so it will be, my feature vector x will be classified into omega 2, because this and this these two suffixes cannot become the same. This alpha 1 and omega 2, this 1 and 2 cannot become same, means it cannot become 1 1 or 2 2 like this, then it is the ideal case. And we are not talking about the ideal case. If this is the ideal case, then the loss function will become 0. Okay, so this is not the ideal case. We have to minimize the value of this loss function, as I told in the last video, as much as possible. Okay, so lambda alpha 1 and omega 2, or lambda alpha 2 and omega 1. Is it clear up to this point? So if this point is clear, so we progress our discussion. So how do we write over here? Lambda, say alpha I slash omega j. Okay, and I and j will belong to 1 comma 2. This is the thing. Okay, this is the set of 1 2, and I j will belong to 1 2. Lambda alpha I and omega j. Now for notational simplicity, see, when we are making derivations or we are solving problems, each and every time I cannot write such a big function, no, lambda, then again a first brace, then alpha I slash omega j. It's not possible always. So what I do is I make a simple notation, lambda ij. Okay, these two terms are equivalent. These two terms are equivalent. Either you write lambda alpha I omega j or lambda ij. So we will now use this notation because the same thing. Okay, we will now use this notation because it is easy to write, not like giving first brace and then again putting a slash each time. So whenever I write lambda ij, then the reader will understand that it is nothing but actually the loss function when the action is alpha I and the class is omega j. Is it clear up to this point? So if this is clear, then I read further that when the true state of nature is omega j. If we write the conditional risk given in equation 13, all of you please look into equation 13. Equation 13 was nothing but last class we had studied r alpha I underscore r alpha I slash x bar, means the feature vector is x bar. Okay, in such a case the action is alpha I and we have to find out the conditional risk. So we had made the derivation last class, that is equal to summation over all j1 to c, because there are c classes. Over here it will be j1 to 2 because now there is two classes. So lambda alpha I slash omega j dot p omega j slash x bar, means the product of the individual loss function and the posterior probability. So we will now expand this and write this in case of two class problems. So over here it will be summation over of, let me first write down the equation, r alpha I slash x bar is equal to what it is, summation over of j1 to c lambda alpha I slash x bar dot p omega j slash x bar. Okay, lambda I omega j means the loss function when I am taking alpha I, considering my class is omega j and the posterior probability p omega j slash x bar. It's written in the PDF. You can, if there is handwriting problem, you can check in the PDF. Okay. Now let's expand this term in case of two class problem. So how it will look like over here? So we will have over here, so I becomes 1. Okay, because there are two classes and so two decisions. So we will have r alpha 1 slash x bar, that is equal to, now we will remove this summation sign and we will expand it. Okay, so how do we get? So this lambda alpha I omega j, I just now explained you that we will be writing it as lambda ij. So what it will become? So it will become, please guys, you take a note copy, okay, and write down the equations yourself. Lambda 1 1 P omega 1 x plus lambda 1 2, yes, P omega 2 x bar. So this will be my first equation. See, r alpha 1 x bar, that is equal to lambda 1 1, okay, because lambda ij, so I is 1, j is also now 1, P omega 1 x bar, okay. Now lambda I is same and omega now becomes 2 1, this is omega 1 and this is omega 2 and this is alpha 1, okay. Then P omega 2 x bar. Now this you can rename this equation as equation 14. This will be your equation 14 as per your PDF. Now similarly, we construct R alpha 2 x bar, that is equal to what it will become, lambda. Now this decision is alpha 2. Previously it was alpha 1, now it will be alpha 2. So we will write lambda 2 1. Then P, what it will be, omega 1 x bar plus lambda 2 2 P omega 2 x bar. So please rename this equation as equation 15. This is equation 15. If this is done, the handwritings, I hope it is clear. I have made the light arrangements such that, and also there is also the PDF. You can also see from there. Okay, now I rub this equation. So 15 and 14. Okay, so we will choose that value of lambda which is less, isn't it? We will choose from equation 14 and 15. We will choose that value of lambda which is less. Okay, so now if we do, there are variety of ways of expressing the minimum risk decision rule, each having its own minor advantages. The fundamental rule is to decide omega 1 if r alpha 1 x bar is less than r alpha 2 x bar or vice versa. So see guys, if r alpha 1 x bar is less than r alpha 2 x bar, if this is the case, what will happen? This risk of taking decision, this is alpha 1, so the decision is in favor of omega 1, and this is alpha 2, that is the decision is in favor of omega 2. Okay, if this risk is less than this risk, so what does we want? We want the risk to be maximized or minimized? Of course the risk will be we want it to be minimized. Okay, so if this is less than this, then what we will do? We will take decision is in favor of omega 1, means this feature vector x bar will be categorized under omega 1, that is alpha 1. And if it was reverse, like if say if this was the case, say r alpha 1 x bar is greater than r alpha 2 x bar, then we would have taken decision in favor of, we would have taken alpha 2 decision, that is alpha 2 decision is nothing but categorizing this feature vector x bar under omega 2. Okay. Now keeping this thing in mind, if this portion is clear, we make a slight change. We write r alpha 1 x bar is less than r alpha 2 x bar. This was my first case when I was taking decision in favor of class omega 1. This was my first case. Now, if I shift this term to this side, means to the right hand side, so what will it become? R alpha 2 slash x bar subtraction R alpha 1 slash x bar is greater than 0. Yes, this term goes this side. So r alpha 1 slash x bar, if it goes this side, it will become negative. So I just change sides and I write r alpha 2 slash x bar minus r alpha 1 slash x bar is greater than 0. Now you have already in equation 15 and 14, we have just now derived what are the values of uh, r alpha 2 slash x bar and r alpha 1 slash x bar, that is lambda, in we had expressed in terms of lambda. So it's my request to the students, without seeing the blackboard, okay, you please try to write down, you please try to expand these values. In equation 15 and 14, you have just right now expanded in terms of these equations in terms of lambda, isn't it? Just write down, expand this term in terms of lambda and expand this terms in lambda and see what is the result, okay. It's my request to the students, please don't look at the blackboard and try to write down. So I get lambda 21 p omega 1 x bar, lambda 21 p omega 1 x bar plus lambda 22 p omega 2 x bar, this is my r alpha 2 x bar, subtraction, I write it over here, minus lambda 11 p omega 1 x bar minus lambda 12 p omega 2 x bar. Now rearranging the terms, if we like say take p omega 1 x bar as common, we will get, means rearranging these two terms and then rearranging these two terms, we get lambda 21 minus lambda 11 p omega 1 slash x bar plus lambda 22 minus lambda 12 p omega 2 slash x bar is greater than 0. See, that's what is written in the equation. Lambda 21 minus lambda 11 p omega 1 slash x bar is greater than lambda 12 minus lambda 22 p omega 2 slash x bar. So, what they have done is actually they have kept omega 1 slash x bar on the left hand side and omega 2 slash x bar on the right hand side. So let's try in that manner also. So this was our final thing, okay. So if I keep lambda 21 minus lambda 11 p omega 1 slash x bar, okay, is greater than, now if I just keep this term on that side of 0, so because if I send this entire term on this side of greater than sign, it becomes, this minus becomes plus and this plus becomes minus. So it will become lambda 12 minus lambda 22 p omega 2 slash x bar lambda. So this is our final equation. Lambda 21 minus lambda 11 dot p omega 1 slash x bar. I was having plus lambda 21 minus lambda 12 p omega 2 slash x bar greater than 0. Now I put this entire term, that is p omega 2 slash x bar, on this side of greater than sign. So what happens? This minus becomes plus and this plus becomes minus. So it will, instead of having lambda 22 minus lambda 12, we will again have lambda 12 minus lambda 22 dot p omega 2 slash x bar, and this is my equation 16. Just check the PDF. Just check the PDF. This is my equation 16. So if we are done through this, now I start reading. Ordinarily, the loss incurred for making an error is greater than the loss incurred for being correct. And both the factors lambda 21 minus lambda 11 and lambda 12 minus lambda 22 are positive. Please underline this line. That both the factors, these two factors, lambda 21 minus lambda 11 and lambda 12 minus lambda 22, both are positive terms. Okay. Thus, in practice, our decision is generally determined by more likely state of nature, although we must scale the posterior probabilities by the loss differences. By employing Bayes' formula, we can replace the posterior probabilities by the prior probabilities and the conditional densities. This results in the equivalent route to decide omega 1. See, if look at equation 17, I will not write it down. The same equation, what was my equation 16, they had written down again. The same equation is in equation 17. Please follow the PDF. So we have over here lambda 21 minus lambda 11 dot p omega 1 slash x bar, okay, is greater than lambda 12 minus lambda 22 p omega 2 slash x bar. Okay, we have to write lambda 21 minus lambda 11 p omega 1 slash x bar is greater than lambda 12 minus lambda 22 p omega 2 slash x bar. Now as per, remember Bayes theorem, so these two are the posterior probabilities. Bayes theorem says that posterior probability is nothing but the product of likelihood or the state condition probability density and prior probability divided by evidence. So what I can write, if I write it down freshly, lambda 21 minus lambda 11. Now we can replace this by Bayes formula. We can replace it as P x bar slash omega 1 dot P omega 1 divided by P x bar. Okay. That is greater than lambda 12 minus lambda 22 dot so I have little less space over here, so I write this entire thing over here. Okay, please don't confuse. I have very less space over here, so I write this entire term over here. That will be p x bar slash omega 2 dot p omega 2 divided by px bar. This is as per Bayes formula. You have to go through Bayes formula. I will not repeat it every time. Okay, in order to understand why I had replaced these two terms by this entire thing, you have to read the study Bayes theorem. Okay, already explained in video as well as in class. Now this and this terms get cancelled because evidence has very little importance. Okay, already explained. So what I will be left with, so now equation, please guys follow equation 17. So we have lambda 21 minus lambda 11, this term, dot px bar slash omega 1 dot p omega 1 is greater than lambda 12 minus lambda 22 dot px bar slash omega 2 dot p omega 2. This will be my final term. So if this is, I rewrite this thing. I rewrite this entire thing now, guys. See. So I have lambda 21 minus lambda 11 p x bar slash omega 1 dot p omega 1 is greater than, again I write it over here, lambda 11 lambda 12 minus lambda 22 p x bar slash omega 2 dot p omega 2. Now if I change the terms, see, px bar slash omega 1, I keep over here. Left hand side we have this term, I keep it as it is, x bar slash omega 1. And I put this term down, this term. So here it is multiplication, so if it goes this side, it will become division. If I change sides, if px bar slash omega 2. And over here we have lambda 12 minus lambda 22. Okay. Now if I put this term over here down, so it will become lambda 21 minus lambda 11. On top of here we have p omega 2. And if I bring this term down, we have p omega 1. This is my equation 18. This is my equation 18. Just look. It is very clearly given over here, px bar slash omega 1 by px bar slash omega 2. That is the ratio of likelihoods or state conditional probability densities, that is equal to lambda 1 2 minus lambda 2 2, lambda 2 1 minus lambda 1 1, that is subtraction of the loss functions. These two terms already explained, they are positive terms, okay. And then the ratio of priors. So it is written, this form of decision rule focuses the x dependency over here in the right hand side. Sorry, this is not equal, this is greater than sign, okay. In the right hand side, do we have any evidence or any x term? No. X bar term? No. So this equation is free of any x bar, means any free of any the feature vector or the evidence, okay. This form of decision rule focuses on x dependence of x bar dependence of the probability densities. We can consider p x bar slash omega j, okay, a function of omega j, that is likelihood functions, and then form the likelihood prior p x bar slash omega 1 by p x bar slash omega 2. Thus, bias decision rule can be interpreted as calling deciding omega 1 if likelihood ratio exceeds a threshold value that is independent of observation of x bar. Just see the final form of this equation. So, you are going to take decision in favor of omega 1 because this term is, the loss associated with this term is less compared to the loss associated with this term. If so, if we can also define bias formula or bias theorem in a different way, that first we do a ratio of the likelihoods, okay, and if we find that the, if it exceeds 0 or if it exceeds 1, if this particular term exceeds 1, then we will take a decision in favor of omega 1, otherwise the decision will be taken in favor of omega 2. So this is another form of defining bias theorem. Bias theorem we have already defined in the first glance, like p omega 1 posterior probability is equal to product of likelihood and then prior divided by evidence, okay. Now I define bias theorem in such a manner, so now in that case I didn't have to take a decision. Now I have to take a decision that whether I'm going to categorize, whether I'm going to take alpha 1 or alpha 2. Alpha 2, alpha 1 means taking decision in favor of omega 1, alpha 2 taking decision in favor of omega 2. Now, so for this to achieve, what we are going to do, we are going to take a ratio of the state conditional probability densities or the likelihoods, okay. And if that exceeds 1 and if the ratio of the likelihoods exceeds 1, okay, then decision will be taken in favor of omega 1, otherwise decision will be taken in favor of omega 2. This concludes my two category classification. So the rest I'm going to again cover in next video. Thanks a lot for watching.